Hello everyone. Today I will talk about the effect of cinnamon hydrochloride and nitrate supplementation on in vitro and in vivo methane production and productivity of cattle. My name's Sathaphon Pelijit. Outline Introduction Material and Method Result Discussion Conclusion Introduction Methane emission China has dual ranked national emission of anthropogenic greenhouse gases, producing 7.467 million tons carbon dioxide equivalent in 2005. Substantial risk in agricultural greenhouse gas emissions is anticipated if livestock production continues. One approach is to modify hydrogen flow environment to decrease use of hydrogen for methane production by using it to reduce nitrate to nitrite and ammonia. Cinnamon hydrochloride Cinnamon hydrochloride has been shown to be effective in increasing growth and improving efficiency in a range of livestock species. Therefore, the objective of the experiment was to investigate whether nitrate and cinnamon hydrochloride are capable of inhibiting methane production and improving growth performance of cattle. Materials and methods. In vitro incubation, a random mixing box design was used in conduct an in vitro incubation experiment with replication over days. Fig 1 control group, Fig 2 cinnamon hydrochloride group, Fig 3 nitrate group. In vivo experiment, a completely randomized design was used to determine the effect of nitrate and cinnamon hydrochloride on LPG intake of DM, feed conversion ratio, dairy, methane production, and methane yield of cattle. Animals, feeding, and housing. 12 Chinese series of the yellow cattle breed, weighing with high 236 kg live weight and approximately 12 months of age were individually raised in an enclosed state, and the experiment lasted for 56 days. Cattle were allocated 2 treatments for animals per treatment, using stratified randomization based on LW, so there was no significant difference in starting LW between treatments. The birth cell diet was 70 per 30 blend of Chinese ranked hay with much Chinese and gross meal concentrate based on corn and grain results. This table shows red box 1 CP4 production of methane. Nitrate did not separate over fermentation. It didn't suppress propionate production and gravity reduction. Methane production in association with a more than fourfold increase in hydrogen accumulation. Propionate in the red box 2. In contrast, nitrite has a general suppressive effect on fermentation, reducing total VFA and propionate concentration, and reduce rumen protozoa populations relative to control result. Nitrate and silicium hydrochloride supplementation associated with lightweight, both 3 weeks and 6 weeks, are not significant. Nitrate supplementation associated with protein digestibility, both 3 weeks and 6 weeks, were higher than silicium hydrochloride because nitrates contain more nitrogen than silicium hydrochloride. Conclusion: even though the reduction in total dairy methane production by silicium hydrochloride was non-significant before that silicium hydrochloride significantly decreased the methane production rate of cattle up to 6 hours post-feeding in a similar time course. In contrast to silicium hydrochloride, which gives a small short-term methane mitigation, nitrate lowered methane production by 55% in vitro, while reducing its production by 30.9% in vivo. Nitrate has been rated as one of the leading options for livestock methane mitigation, with this used in supplements recognized as a means of earning carbon credit in Australia's carbon farming initiative. Conclusion: in this small study, neither silicium hydrochloride or nitrate supplementation delivered both of the distillate chains of significantly increased live weight gain and reduced dairy methane production. Importantly, the in vitro study showed there is a direct effect of silicium hydrochloride on rumen microbiota that changed protozoa numbers in rumen register and increased hydrogen accumulation. Increased nitrate solid are greater and more sustained methane mitigation effect but dimethyl intake LWG and FCR were not affected. Acknowledgement. The study in part of high quality beef cattle breeding technology research and development cooperation project. Andrew would like to thank the Chinese Ministry for National Foreign Financial Support, also Mr. Wang Hao, for supplying equipment and technology. Reference. Thank you.